Propane is one of the components of gas that is used as a fuel in homes. You're given the unbalanced equation, you need to balance it. The first thing you need to do with balancing of equations is that you need to, when you've got a big equation like this, an organic equation, is to say how many carbons have I got? 3 on both sides now. How many hydrogens have I got? 8. 8 on both sides now. Then worry about the oxygen. So I've now got 3 times 2 is 6, 4 times 1 is 4. That means I've got 10 oxygens, so I need to put a 5 over there. So my correct answer on that one is the answer C. Propane is one of the components of the gas that is used in the fuels of homes, and now we need to work out what is the net energy released by this combustion. So let's do this calculation now. Firstly, I've got to draw out propane for you. You've got 1, 2, 3, 4, 5, 6, 7, 8 CH bonds. So it's 8 times 413, which is going to be equal to 3,304. Plus, there are 2 carbon-carbon bonds, 2 times 347, which is equal to 694. And I've also got 5, remember, let's just put these balancing numbers in here, 5 oxygens, so it's 5 times O double bond O, which is 498, and that's going to be equal to 2490. So on the left-hand side, all together over there, in order to break bonds, I will have needed 6,488 kilojoules of energy. On the right-hand side at least, I am going to have 3 times, remember what carbon dioxide looks like, I'll draw it over here. It has 2 double bond O's in it, so you've got, and there are 3 of those, so altogether I've got 6 COOs, which is 6 times 803, and that's equal to 4,818. Plus, I've got 4 waters, remember what water looks like. So I need to break that and that, so it's going to be 4 times 2, which is 8 altogether, times 464, and that comes in at 3,712. And so altogether, how much energy is released? 8,530 kilojoules, and when I subtract those two, I land up with a number of 2,042 kilojoules per mole that is released. More energy is released than taken in. So my correct answer then is going to be B. Which of those is an exothermic graph? These are classic shapes that you need to learn, and this is my classic exothermic diagram. Now we're going to look at definitions. There are 4 different definitions over here which you need to put into your notes and you need to have as something that you can regurgitate in a test. Firstly, what is an endothermic reaction? It is defined as when heat energy or thermal energy is transferred into chemical energy. In other words, I take in heat and make chemical reactions. What is meant by the heat of the reaction? It is the net change of chemical potential energy of the system. What is activation energy? The minimum energy required to start the reaction. What is an activated complex? A temporary transition state between reactants and products. Which of the following is not an example of an exothermic reaction? While a fire gets hot, a battery makes energy. It makes electrical energy, so that's exothermic. A reaction where delta H is negative is exothermic. A reaction where thermal energy, heat, is made into chemical, that is an endothermic reaction. And therefore, D is your correct answer. It's the only one that's not exothermic. And which of the following best represents the energy profile of an endothermic reaction? That is your classic endothermic energy profile diagram.